There's three main ways we can transfer energy. Heat is basically that energy transferred between the objects, and what's interesting is that stuff always flows from hot to cold. Okay, so the way I think of it is that the hot things are basically trying to warm up the environment. So when we say our cup of coffee got cold, the reason is that cup of coffee was hotter than the room, and so that cup of coffee was trying to heat the entire room, and obviously that doesn't work because the coffee's not very big, and so that cup of coffee sent all of its energy to the room until it became the same temperature as the room because it wasn't able to heat up an entire room. And there's three main ways that we can transfer heat. The first one is conduction, and this is when objects are in direct contact. You have to be touching to have conduction. Okay, you must be touching. So when you a lot of times they'll ask you, is this conduction or is this convection or radiation? If you have two things that are touching, you know that it's convection or conduction, excuse me. Convection only occurs in fluids in a liquid or gas, no solids. And basically when you see that things, you have a situation in which the air or the liquid is kind of moving in a circle, then you know that that's convection. Sometimes they talk about a ceiling fan. Okay, I can't draw ceiling fans very well. We'll pretend that's a ceiling fan. Ceiling fans will take the hot air in the winter and move it down and take cool air in the summer. You can talk about a convection oven. Okay, a convection oven uses air, moving air, in order to cook your food evenly. And then we also even have convection currents in the ocean where we're moving different temperatures of water. Okay, so that a convection current is just a movement of a fluid that rises and falls. So it moves in a circular pattern. So if you see something moving in a circular pattern, you know that is convection. And it can only happen with liquids or gases. It will never happen with solids. And then radiation does not require physical contact. There was no touching. And the way I remember radiation is we get sun, or we get energy from the sun through radiation. And so we're obviously not touching the sun because that radiation is going, that energy is going from the sun through outer space to the earth. Okay, so this is radiation. You're not going to have touching, and that energy is not going to be touching, but it's still going to hurt. You'll still feel it. If you have a fire, this is supposed to be a fire. I'm not a good artist, which you guys know. And then if I had my hand, I had it. This is a mitten because I can't draw fingers. And my hand is not touching the fire, but it's close to the fire. The heat from the fire is going to radiate towards my hand, and that's going to be radiation because I'm not touching the fire. Okay, if I was touching the fire, that would be conduction. Okay, so to recap, conduction is touching, convection moves in a circular pattern and does not work with solids, and radiation has no touching whatsoever. So then we can talk about thermal equilibrium. When we talked about our cup of coffee and it got cold because it was heating up the room, when the coffee and the room are at the same temperature, we consider that thermal equilibrium. Okay, so this could have been our coffee, and this is our room. Our coffee is trying to warm up the room. It obviously doesn't have enough energy to do that. So then our coffee and our room are going to reach equilibrium where they're at the same temperature, and so that means they are at the same kinetic energy. Remember, your warm objects are trying to warm up the energy to their temperature. You never have something going from cold to hot. It just does not happen.